Hi everyone, welcome to the video. We are going to solve level order traversal. In this question, we are given a binary tree with n number of nodes and we have to traverse level by level. How we'll do it? See example 1. See as in a staircase. Cool. 1 is at a level. Okay. And then its children. Can be left children, right children, both or any of them at the other level. See 3 and 2 are at the same level, but they are at different level than the root element which is 1. Hence, 1 came alone, then 3 and 2. From the left towards right. 3 and 2 are at the same level. Cool. Similarly, in example 2, see, root element 10 is at a level, and its left child and right child are at a different level, which is 20 and 30. Cool. But we started from the left and we moved towards right. Cool. Then 40 and 60, which are the left and right child of the left child of the root, are at another level, 40 and 60. From left towards right. Thus, our answer will be 10, one level, 20 and 30 at another level, 40 and 60 at another level. And that is our answer 10, 20, 30, 40, and 60. Level by level as a staircase. Cool. But you have to start from left and go towards right. How will do this question? This question is pretty similar to BFS, and that is what we will try. First of all, I will import BQ from collections. That will help us without any hassle. We'll start from the left and move towards right. So we'll create a queue of type DQ, and first we'll store root inside it and result list, an array called rest to store the level order traversal so that we can return it at the end. Now while there are elements in this queue, so first of all it has element I inserted root inside it, and we will pop them one by one and we will successively insert one by one. Okay, cool. First of all, I will create a temporary variable that will pop the queue element from the leftward side. Okay, now to begin with, we have only root. It has only one element, whether it be left or right. Okay, that will get popped out. But as we move ahead and we write further our algorithm, there will be left child or right child, or both or either of them. Cool. Now that we have popped it, the element which was present in the queue, okay, we'll append this in the result array. Temp.data. We don't need pointer, we don't need location, we only need the data. Cool. Now there will be a check if it has left child or not. First, if temp has left child, sorry, temp left child. If temp has left child, append this element, append this left child to the queue. To the queue. Left of temp will get appended to queue. And similarly, this process will continue. Okay. Now they can be right child also. So we will check temp dot right. If it is right child of that particular node temp. If it is appended to the queue, added to the queue. After we have traversed all the elements which are there in queue, and when the queue will become empty, we'll come out of this loop. And at that time we will return the result array which we have formed thus so far. Let me submit and check the efficacy of our solution. Yeah, as you can see, it did the job pretty effortlessly in very less time. So I hope you learned a new concept and enjoyed it. Thank you. Have a very nice day.